Stat 201.
Hey Brian, what's up?
Hey Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!
Hey everyone, Jason here. We've tried to find someone to do the Kahoot. You know what though? We could just try and bring him back. I happen to have this. So we'll see what happens.
Hey everyone, how are we doing? Just switched shirts between the transition right there. We've got Elizabeth into the chat. We've got Cora in the chat. We got Braden in the chat. We got Jasmine and Molly and Noelle and Savannah. Who's here? Say hi, because we're going to be starting Kahoot in just a second. Drew, good to see you there. Savannah, Caitlin, good to see you. Mewbot's here giving out points. So once again, we are glad to have everybody. I should be logging into Kahoot right now as we speak. And I got to say, this guava monster, pretty good. We got Sarah here, and Sarah's a pro. Let's throw 2,000 points. I want some W's in the chat for Sarah, because Sarah has been on the Discord answering questions even faster than me, and she's one of our new Discord mods. Got that monster? Yes. It's a sadly an addiction, Braden. Sadly an addiction. W's in the chat for Sarah right there. Huge help. Really appreciate it. Once again, it's just out of the goodness of Sarah's heart, but also I'll advertise for Sarah right here. Sarah does tutoring. So Sarah, if you want, you could put your information, rates, or anything. Just firsthand, I've seen that they have knowledge when it comes to statistics. And if you're a part of the Discord, we always try to get people involved with learning from each other and working together. And you could hire a personal tutor to learn. Just depends. Everyone has a different learning style. Even this, I'll say this, my wife, who's a genius, got a tutor for one class because I think she made like a C on a test, and she's like, I don't make C's. And then she aced the class. And just all depends on what you need. But I think sometimes we need, there we go. Let's pin this message right here. I like this. Pinning the message right there from Sarah. So advertisement here at the start. And I think it's like, everyone has different strengths and weaknesses. You put me in an English class, I'm gonna need a tutor, even though I've been speaking English my whole life. I'm gonna need that tutor for the English class. For some reason, I'm just not that good at it. And I'm hoping, I reached out to one of my former English professors, and I'm hoping I hear back because I've got a last lecture I'm doing and excited. But we have a huge Kahoot. Now, what I ask you to do before the Kahoot starts is go and get the what, which Mewbot is going to put in the chat. So before the Kahoot starts right here, it'll be about an hour and a half. Don't worry, it will be recorded. Elizabeth, I think you'll be able to see most of it. It's 38 plays. I was like, 38 questions, that's a lot. We got 3,000 people play the Kahoot, 25 questions. The formula sheet, people are saying it right there, the formula sheet. You'll see Mewbot has it. I'm not going to pin it because I want to leave Sarah's comment as the pinned link for a little bit. So reach out to Sarah if you're interested in some tutoring and discuss. Make sure to go get the formula sheet. Let's show where to get the formula sheet. And we'll call this segment right here before the Kahoot starts, preparing for the exam. Okay, let's go and put a section in this video. How to prepare for the exam. Okay, let's go check it out. So right now, if you're in this Kahoot, you will see Mewbot has dropped this link in the chat. This can also be accessed from the stat21.utk.edu website. You can see all the exam reviews right there. I clicked exams, so now I have to click exam 2 review again. But you can see the links and also check out the Stat21 webpage. Now, you can either print out the formula sheet or you can write it out. Do not have additional things. You're not allowed to have notes on this exam, but you can have the formula sheet. Check out yesterday's office hours. And what I'm going to do is I am even going to go and grab you the link to yesterday's office hours and drop it in the chat right here. And if you go to yesterday's office hours, 59, I like it. Let's get 100 people watching. Here's yesterday's office hours. I was wearing the Mario t-shirt. And what did we do? Who can say it in the chat? What did we do during yesterday's office hours? What did I put in yesterday's office hours? I did what? I went through the complete what? What did we do in yesterday's office hours? Say it in the chat for some Mubot points. Gotta make sure people are here and they're awake. That's why I get afraid no one can hear me. Anybody? Bueller? What did we do? You're seeing what we did. Yes. We went over the whole formula sheet, and I think the chat just paused for a moment. You were right. So I should always, when it pauses, I'm like, are we still online? So you can see it's broken down into sections right here where I went over sampling distributions. We did some example questions. This is a harder chapter. So really, I was kind of rushed at the end because we were running out of time, but I went over probability, did a lot of probability questions, talked about disjoint, mutually exclusive, independent. You can even see the rules in here. So I'm literally telling you right now that the start of this Kahoot may deal with things like this. So please have the formula sheet open. I actually found my paper formula sheet from 2023. Nice. Throw points for Lindsay right there. Write it out, know how to talk about it, know how to explain these things. Because the questions you're going to see in the Kahoot will be kind of answered by this, such as like residuals or the rules of probability or how sampling distributions work. And also, if you're wondering what is on the exam, the answer for what is on the exam can be found right here with the topics. You can see all the chapters on the exam right over here. There it is, chapter 7, chapter 8, chapter 10, chapter 12, chapter 13, and 14. I know it's a lot of material. Check out, if you're worried, the review videos. Here's the review videos right here going over sampling distributions, probability. So that's chapter 10, chapter 12, chapter 13/14. You go down here, you've got test question reviews on this page showing you how to work out each question. I try to make these videos short. You notice this is 5 minutes, but you see me answering each of the questions with random 10% pause. I saw Braden putting some pause in the chat. And since this is, I believe, categorical, it's going to be success, failure. And you can see just working through the problem, explaining it and why we solve out for these different things. I would suggest working the practice test. And then you've got your classic speed run videos right here. So definitely Braden knows pause right there. You got it. So if you're watching this right now, hopefully it's not Monday night. If it's Monday night, it's all right. What I ask you to do when it comes to test 3 is to start a little earlier, because the more you hear these things, the more they make sense. I like Brandon right there. And so you can see test 3 materials already up. You already got speedrun videos with randomness right there. You got speedrun videos for test 3. We're not doing test 3 right now, but you can already see the material will be uploaded with the review material, and you can already see what test 3 will look like. So if you're wondering what test 3 looks like, it's already videos up for it. Where's the link for the Kahoot? Well, that's what we're going to get started right about now. What do we need right here? We need an I'm ready in the chat. Thank you so much, everybody, because I need some I'm readies. Who's got some I'm readies? Because it's almost time to Kahoot. If you don't say I'm ready, then we can't do it. I'm ready in the chat. I'm ready. Let me make sure I'm not ready. We're loading up Microsoft Word so Brian can show you how to do these things. And we got Lindsay ready, we got Jay ready and Lewis ready. Well, guess what? Since you're ready, in 3, 2, 1, I'm also ready. Here we go. The Kahoot is on the screen. You can scan the code or you can put in the number. And I think we have everything going right here. So let me put in the notes right here. I'll put when we start the Kahoot. But everyone start joining in. Inspired Bobcat, good to see you there. Aquatic Panda. So many people. How many people do we have watching? It is time, and we got 25 questions to go through. I got a bunny name. Ooh, Sarah. There are prizes for the winner. I still have Kahoot t-shirt. I'm grabbing the... Oh, I got a lot. Kahoot was so nice to send me t-shirts. And we love the bunny names. I have a medium. I'll wear a medium. Medium Kahoot, XL Kahoot, medium Kahoot. I think these are soft too. I want to take one. Medium. Why do I have so many mediums? I thought the mediums would go. This is a medium. Medium. Love, yes. I have one XL in all mediums. I got like 5 or 6 mediums and 1 XL. I need to wear Kahoot. I'll be a billboard for them. It looks soft, Sarah. Is it soft? Like, all my t-shirts are soft. My wife knows. She'll go to stores, find a decent design, and touch it and be like, it's not a soft t-shirt. Brian likes soft t-shirts. Soft t-shirts. I have a really cool Mega Man shirt. It's like cardboard. We have 55 people playing. How many people do we have watching? 62. So we're going to get probably started in a second as I take a sip of my guava monster. I would have to well, thank you, Braden, right there. You tell them, send them this right here. Send them, we're talking monster at Stat 201. And I would have to double check before we did any sort of, be the first professor of a college. Technically, Haslam calls me professor. I don't have my PhD though. So, I mean, it's very kind of them, very nice of them. Well, now, I already had you say I'm ready, so I can't have you say it again. It is time to learn in 3, 2, here it goes. 3, 2, 1, let's go. 2 events that can be easily added together must be what? 2 events that can be easily added together must be what? What should you be looking at if you get this on the test? You need to look at your what? You need to look at your what? Say it with me in the chat. Remind yourself of this. You need to look at your formula sheet. Great job, Tommy, right there. Yes, look at the formula sheet, which MuBot is going to put in the chat right here. So you need to go to this link. I am so sorry. I don't want to be over here right now. We will look at that in a second. I already clicked the link. You will see we will go to the formula sheet and we will see the answer. So don't worry if you get it wrong. Just remember, the formula sheet has the answers. So I can't repeat it enough that if you know what the formula sheet says on it and you know to look at it, you can often get answers to questions like this, and you can make sure you're doing it right. And we did pretty good. But remember, formula sheet. Where do we see on the formula sheet adding together 2 events? Where do we see it on the formula sheet here? Where do we see adding together 2 events? Where do we see adding together 2 events? Like, are there words around here where it says adding together 2 events? Probability of A or B. Great job. The probability of A or B is the probability of A plus B, where A and B have to be mutually exclusive. Wait, why was there 2 right answers? Mutually exclusive disjoint? Why are those 2 right answers? Why? And great job, Jay, right there. What? Wait. It says mutually disjoint is right and mutually exclusive is right. It's the same thing. They mean the same thing. Great job, Elizabeth, right there. Mutually exclusive means if one thing happens, the other thing can't. It's like you go to the pet store and your parents say, you're either getting a dog or a cat. Say, can I get both? They say, no, it's mutually exclusive. You get one, you're not getting the other. Now, you could get neither, and that is still the idea of mutually exclusive. Like, you just can't have both happen. You can't get a dog and a cat. Other things that are mutually exclusive, my classic examples would be that we have like 100 degrees outside and snowing. It can't be 100 degrees and snowing at the same time. So you say, is it 100 degrees? Okay. Can it be snowing? It can't be snowing. It's impossible. So that makes them what we call disjoint, as though they have no overlapping, like a Venn diagram where they have overlapping. They'd be called disjoint, which is the same thing as mutually excluding each other. This would be mutually inclusive. This is mutually exclusive. Inclusive, exclusive, inclusive, exclusive, disjoint, not disjoint, like they share a joint together. I'd be concerned if it's 100 degrees and snowing too. It's like, what's going on? So watch out. Make sure you know what disjoint means. Make sure you know what mutually exclusive means. Make sure you know what independent means. Make sure you know what dependent means. And look at that formula sheet if you ever get a question like this. Next question, or leaderboard first. The leaderboard doesn't animate when I go over here, and I don't know why. I feel like there should be something here like animated leaderboard. Does anyone see over here where it has like animated leaderboard? Because I've lost this for so long. Automatically progress through questions and join the... No. I've never had... My animations got lost here a long time ago and I miss it. And I don't know why. And I don't see it. Worry about that another time. Next question, let's do it. 2 events that have no influence on the probability of each other. This is like Brian drinking coffee and Darren drinking coffee. As The Rock would say, if Brian drinks coffee, it doesn't matter. It doesn't matter if Darren drinks coffee, or Brian drinking coffee would not influence in any way the coffee drinking behavior of Darren. So what would this be? Now, what's interesting, if something is disjoint things are very, very what on each other? Nice job, Noah, right there. Whoa! 2,000 points. Wow. I'll take that. Disjoint events are very dependent. That's a factoid. Disjoint events are very dependent because, I'm proud too. What do I mean by this? And this is unrelated to this question. Think about this. Can you make an A and an F in the same class? Like this semester, can you make an A and an F in the same class as an overall grade? Not like on one test and another. Can you make an A at the end of the semester in a class and an F in that same class? You are correct, meaning they are what? Now be careful, just the idea that if you make an A in that class, you can't make an F. Like you say, I made an A in this class. Your parents say, did you fail it? And you're like, I already told you, because these things are what of each other. I already told you the answer to that, mom and dad, because they are what of each other. I can't make an F. Boom, MSA right there. They are disjoint. They are mutually exclusive. Mom, dad, they're disjoint. If I make an A, I can't make an F. Making an A means I didn't make an F because they can't happen at the same time. But wouldn't you say, and Emma and Noel are correct, they are also dependent. That is true. Because disjoint things are dependent. Because if you make an A, you no longer can make an F, which influences the probability. Now be careful, be careful. Don't think of dependent as disjoint. That's where people get into trouble. Because does snow depend on the temperature outside? Yes or no? Just think about, don't worry about stats. Just think of if someone says, does the snow depend on the temperature? Or like, does the temperature depend on snow? Yeah, they do. Like you say it's snowing, you would know something about temperature. Can it snow at the same time as it is below 32 degrees? Can it be snowing and below 32 degrees? Can it be snowing and below? Yes. So you've just stated in this fact, be very careful with the way I'm doing this right here. It can be snowing and it can be below 32 degrees. By doing this check, by saying they can happen at the same time, you've stated they are what? This is a really good check and good practice. It can be snowing and it can be below 32 degrees. I'm trying to tell you they can happen at the same time. Well, they are dependent, that is true. But with me stating the fact of it can be snowing and it can be below 32 degrees at the same time. What does that mean? It means they are not disjoint. Does that make sense? It means they can happen at the same time, which is not disjoint, not mutually exclusive. But if I say snow is influenced by what temperature it is, I'm telling you they are what? Which it goes back to this question. If I say snow is influenced by the temperature, it is more likely when it is colder, then I am making a statement about the what of the two things happening. Then we're going to dependence. Do you hear the difference? Snow is influenced by the temperature. That's a statement of dependence. If it is snowing, it can also be below 32 degrees, is a statement of not mutually exclusive that both can happen at the same time. Yay. Thank you, Elizabeth. I got to give 2,000 points, Elizabeth, right there. We do go into more detail during office hours. Check out office hours, and I do segment up the videos. So if you want to hear it again and maybe in a different way, more detailed, check out office hours. Going crazy points. That's 5,000 points. What am I even doing? We'll try to make a new level at the end of the Kahoot. But who's winning the Kahoot? Groovy Bunny, Witty Griffin, Hero Jaguar, Joyful Ferret, and Elated Lion. Let's go. Next question. To multiply the probability of two events, they must be what of each other? Look at the formula sheet. Look at the formula sheet. Look at the formula sheet. Before you answer this on the test, because I swear I'm doing a teaching to the test moment. That comes from Jason. I swear, please look at the formula sheet. Please look at the formula sheet. Because you will see on the formula sheet, the multiplication rule requires that things are what? It requires that things are just. Wow. Get an Owen Wilson wow for that. Who did not look at the formula sheet for the first one, but looked at it for the third one? And then you're like, that's easy. Right down here. This is going really well. I've had people miss that one again. For the first one, you might have been like, wait, I was supposed to look at the formula sheet? Wait, saying to tell me to look at the formula sheet? That if I get a question on the test that says something like this, like To multiply two events, they must be what of each other? Independent. That means one event does not influence the other. When would you check to see if things are disjoint / mutually exclusive if you are trying to what them? When would you check to see, which once again, they're the same words. When would you check to see if things are disjoint, mutually exclusive if you're trying to what them? If you're trying to add them, exactly. And the formula sheet literally says this, the word or, like A or B happening, like Brian makes an A or a B in his class. Could we add together those probabilities? The probability of Brian making an A or a B in Stat 201 this semester, if I was taking it. Could we add those together? Could I add together the probability Brian makes an A or a B? Could you do that? Why or why not? You'd have to say if Brian makes an A, good job, Sarah. You'd have to say if Brian makes an A, can he also make a B at the same time? You can't get an A and a B at the same time, meaning they are mutually exclusive. Since they are mutually exclusive, you can or cannot, right? Can or cannot add them. Since they are mutually exclusive, right? Can or cannot add in the chat. Since these things are mutually exclusive, you can add them. If I tell you my favorite football team has a probability of winning of 60% and a probability of losing of 38%, what is the probability they win or lose? So that was win of 60% and lose of 38%. What is the probability they win or lose? It could say or. Sometimes you have to figure out that we're trying to say or, and Aiden has it 98%. Because you could probably win, lose, or tie, and the tie would be the remaining 2%. You also see the complement rule as like, what is the probability they do not win or lose? And you could do 2% is the probability of that not happening, which is the complement rule right here. And if we list all the probabilities, that's the set of everything that could occur, and it must have a probability of 1, like win, lose, or tie when added up equals to 1, which covers a lot of the formula sheet right there for probability. So really good work. I just closed down the Kahoot. So let's go back and let's see who's winning. Groovy Bunny, they might have left though. So Hero Jaguar, Aquatic Panda, Witty Griffin, and Tropical Ostrich. Let's do the next question. Here's a tough one. The probability of a gross jelly bean is 25%. If you eat 3 jelly beans, what's the probability they're all good? So you know those bamboozled jelly beans that sometimes there's a gross one? Well, if you're going to eat 3 of those jelly beans, you have to think about the first one is good, and the second one is good, and the third one is good. Now, you heard me say a word right there. You heard me say and. So what do you think when I say and? What comes to your mind when you hear me say and? Like if I say the first jelly bean was good and the second jelly bean was good, you're eating them. You're like, let me eat 3 jelly beans. That was good, and that was good, and that was good. Be careful. Good answer, Savannah. With the word and, we're going to multiply. So multiply with the word and. We go right here on our sheet, and you see down here, and is going to be multiplied. We threw some points right there. Good answers, we're going to multiply. Well, if the probability a jelly bean is gross is 25%, what is the probability it's good? What is the probability? So remember, gross is 25%. It's either gross or good. One of those things must occur. Compliments. Julius, great answers right there, 75%. Lars is on the right track. Because the first jelly bean is good is probability 75%, and which means multiply 75% again, and 75%. So think about it. When you're trying to solve this out, you want to write a sentence. Pretty good work, pretty good. This is a tougher one, like I said, so don't worry if you get some wrong. We're here to practice. Frankly, if we get them all right, then why am I doing this?
It doesn't matter.
Rock knows, but it does matter, Rock.
It matters.
It does matter. Don't say it doesn't matter. So probability, I would write this. Probability of bad jelly bean is equal to 25%. We'll make it bigger. Now you find the what of it. A jelly bean is either bad or good. We'll only define them as that. There's no mid jelly beans. Only bad or good. So what's the probability of good and how do we find that? This is called the complement. We said it earlier, I think. How do we find it? I know how to find it. The complement is found by 1 minus. 0.75. Great answers right there. Subtract. Just subtract. Now, this is called the sample what, which is everything that could occur when it comes to probabilities. Once again, lots of review right here. This is chapter 10. This is called, when I list everything that could occur, the sample what. Sample space, great answer, Grace, right there. This is the sample space. The sample frame is all individuals who have access to sample, where the sample space is the list of everything that could possibly occur. And so with this being the sample space, you have to ask, I eat 3 jelly beans, and they are all good. The first was good, and the second was good, and the third was good. So to think about this, when you're saying good and good and good, good and good and good. Notice how when I say and, I'm multiplying, and good gets the associated probability of a jelly bean being good. Now, this is a little longer to write. Why can I multiply these? Why can I multiply these? Why can I do the probability the first is good, and the second is good, and the third is good? Why can I do this? Why is this a valid probability to calculate? Why is it a valid, why can I do this? Why? Why? So serious. They are independent. That means if I eat one of the jelly beans, it's not going to influence the other jelly bean being good or bad. It's not like I eat this jelly bean, the other jelly bean becomes bad because it was good. Independent means whatever this jelly bean is, it's not going to influence the other jelly bean. What would be the sample frame in the question? Ooh, the sample frame, really good question, Thatcher, which relates to, and we'll throw some points for that, which is a chapter 10 concept. The sample frame, ooh, man, I love it. Does anyone know? I'm going to give it 10 seconds, and then we'll go to the next Kahoot question. Does anyone know what the sample frame would be? Which is a chapter 10 concept, not quite probability, but a good thing to know from chapter 10. What would be the sample frame when I'm eating jelly beans? Probably my what? The sample frame, which is a chapter 10 concept, the individuals I have access to sample. What is the sample frame? Which isn't probability, it relates to sampling. Kinda. I think the sample frame will be the jelly beans in my box. The jelly beans I bought. Does that make sense? Have fun, Braden. Have fun. What is it? Lift heavy weights. Do that right there. The bag of jelly beans here. Drew, great answers. Drew said it right there. It's going to be the bag of jelly beans you're eating right there. Lightweight, Braden. Lightweight. Make it happen. So the bag of jelly beans, the ones you have access to eat, is going to be the ones you could eat from. Can you go over the steps? I thought it was just be 0.75. Good questions. Marley right there. So what is 0.75? And so please, we'll pause on this a moment more. Please ask questions if you have them throughout this whole Kahoot. 0.75 is only the probability of what? 0.75 is only the probability of what? 0.75 is only the probability of what? Not at least one. And that's why we pause right here. It's just that you get a good jelly bean. If I go to my bag of jelly beans and I eat one, 75% of them are good. But if I eat 3 in a row, the first is good, and the second is good, and the third is good has a probability here because each one is good in a sequence. Does that make sense right there? It's the one jelly bean being good has a 75% probability, but me grabbing 3 jelly beans and eating them and they're all good would have this probability right here. Imagine, imagine I have I have a friend who's really good at basketball, and this friend makes 90% of the free throws. If they take 10 shots, what is the probability they make all 10 shots? So if you can do this, this is a quicker version, same question, but my friend is trying to make all 10 shots, and we'll assume that they're independent. So they're a 90% free throw shooter. What's the probability they make the first and the second and the third, assuming independence, which basketball free throws you get problems with? What's the probability they make all 10 shots in a row? The probability they make one shot is 90%. What's the probability they make all 10 shots? And you could just tell me the formula for it. What you would do is say they make the first and the second and the third and the fourth, and it'd be, I think people are solving it, you just raise it to the 10th power because they make the first and the second and the third and the fourth, and you're multiplying every time you say and. So when you hear me say and, it's multiply, and then the probability they make the first and the second, and you multiply probability. Good job, Andrew, right there. So just a little bit of practice, understanding when we say and, we're multiplying. If we say or, we're adding. And requires independence, and or requires disjoint mutually exclusive, because that's addition. Leaderboard, Groovy Bunny. Ooh, it's a different person, not Sarah. We got more bunnies in the chat. Hero Jaguar and Aquatic Panda. Next question. The probability of getting a multiple choice question correct is 80%. With 5 questions, what's the probability you get at least one wrong? Now, these are tougher questions, and I did a lot of at least one problems. I'm going to go find the link to that video while you're doing this one, but it was maybe at the start of this week. I did a lot of at least one problem. What's major number? I don't know. It's a good question. So I'm going to go find those at least one problems, because here's the thing. I can teach you a lot right now. We will practice, we will solve these. But what it really comes down to, here we go, at least one problems, is practice, practice, practice. And I'll show this at the end. To solve an at least one problem, start by doing the following. Write down your probability table. What are the probabilities? So you have 80% probability of getting it right. What's the other probability? 80% probability of getting it right. What's the other probability? Like you just, random question you're taking. 80% probability of getting it right. What's the other one? Take a guess if time's about to run out. 20%. 80% of the time you're right. 20% of the time you're wrong. Now, what would you love for a multiple choice question? If you had 5 of them. You got 5 multiple choice questions. You're about to take them. What would you love? What would you love? I'd love to get them all right. 100% right, right? What's the probability you get them all right? And you'd either get them all right or at least one wrong. Pretty good work, pretty good work. Let's see how this is solved. And I'm going to drop in the chat right here this link. So this link right here, I go through and solve multiple at least one problems. So after this, if you want, check out this link that I just posted, or save it for now for later. For now for later. Sure. And check out this video right here from Office Hours. So in this problem, we are presented with a probability of getting a multiple choice question correct. And so the probability correct is going to be 80%. We immediately go and find the complement by subtracting from 1 to find out the probability of getting it wrong. And we have to think up a sentence right here. This is the harder part for people with these problems usually. So the sentence would be, I either get all questions right, or I get what? I either get all the questions right, or what? So when I take this test right here, I'm either going to get every single question right, or what? And there's usually a big mistake people write. Very common mistakes. At least one. Great job, Noel. At least one wrong. It's not that I'll get them all right or all wrong. I'm either going to get everything right, or I'm going to get at least one wrong. Maybe 1 wrong, 2 wrong, 3 wrong, 4 wrong, 5 wrong. Who knows? At least 1 wrong. And since this is everything that can occur, the probabilities of these will equal to 1. Because I'm either going to get them all right, or at least 1 wrong. Imagine if someone is on a plane, and they say, I need a doctor. It's either the case that no one's a doctor on the plane, or what? Which, let's exclude that person. They're like, wait a minute, I'm a doctor. That'd be great. Because it's either the case on the plane that no one's a doctor, or what? There's at least 1 doctor. Wait, we're all doctors here. I mean, which would be the case, there's at least 1 doctor. There's either no doctors on the plane, or at least 1 doctor on the plane. And so hopefully that makes sense right there in this scenario. And so now we have to change this. First thing we're going to do is we're going to change or to plus. And these can't occur. You can't get them all right and get at least 1 wrong. And so now we have to figure out the probability of getting everything right. And well, let me keep this on the screen so you can see the algebra. I got in trouble for not showing my work when I was a kid. I say, I don't show my work. And I'll tell you story on that in a second. So how do we figure out the probability of getting all the questions correct? How do we figure out the probability of getting all the questions correct? How do we figure out the probability of getting all the questions correct? This means you got the first one right, and the second one right, and the third one right, and the fourth one right. Grace, be very careful. I'm Grace some points. I want to point this out. If you do this, and Grace, we're throwing you 2,000 points. I told Grace to say that answer right there. So thank you, Grace. If you do this, you will notice that your probability does what? If you do this, you will notice your probability does what? Which is the first rule of probability. So with this right here, your probability exceeds 1 or goes outside the boundaries of 0, 1, which means it's not a valid probability. Whenever we're doing probability calculations, they stay between 0 and 1. So good answer and good practice. We will raise it to the 5th power because it actually, when we write it out, if we do the first right and the second and the third and all this good stuff right here, it's going to look like this. So you got to take a moment and write it out completely like this if you want. You don't have to, but that then reduces mathematically to 0.8 to the 5th power. And then you just subtract and you get the probability everyone got. So 2, 3, 4, 5, 1 minus, and there is the probability. Did I do it right? 0.67 is the answer, right? There it is. Does that make sense? These are tough, and check out the link. So the answer is on the screen. The way to get it is over here. This is how to solve in at least one problem. You need to write out your probability table first, have a scratch sheet of paper for the test. Yeah, and these are tougher. And if you don't get these, it's not the end of the world. You can still make an A. They're tougher, but some people during office hours were just on fire and can answer them really quickly. You get the hang of them, they get really simple, but it takes practicing and knowing the steps, and then it's like playing a piano or something. Here we go, the leaderboard. Aquatic Panda. We lost the bunny. Maybe it was. Oh no. Good to see you, Pirate Unicorn. Next question, let's do this. What is the first thing we need to do when solving a sampling distribution problem? This might be a tough one for a lot of people, but there are 2 formulas on the formula sheet. So when you get this, thank you, Elizabeth. So, and when we say office, I forgot, Mubot will say that now. There are 2 formulas on the formula sheet. So that's going to give you a hint of what to answer here. There are 2 formulas on the formula sheet. So what would you do with your 2 formulas on the formula sheet? Make sure to answer. Good job. And we were doing this yesterday. I know sometimes we just jump into marking the notation, but with the 2 formulas on the formula sheet, take a look. This formula right here, these formulas are for proportions. These formulas are for means. So let's give you a quiz in the chat. If Brian is taking a poll of students, and he's told by the registrar the average GPA of students is 3.2, 3.6, and he wants to see how weird his sample is, would he be doing means or proportions? Would he be doing means or proportions? He's told by the registrar the average GPA of students is 3.6, and he wants to go and investigate the average GPA of UT students. So the average GPA of UT students. Noah, let's throw some points. And thank you, Noah, for those comments right there. Noah is 100% right with the comment. I love it when people answer and give the comment. That is exactly right. Noah said because it's quantitative, that's when we use means. Means is for quantitative data. Proportions is for categorical data. So because we were talking about the average GPA of UT students, GPA is like, how much is your GPA? Give me a quantitative number. Correct. So let's do 2 more questions on this. I'm going to quiz you again. How about this one? We want to get the mean for the sampling distribution of the sample mean. The question says, find the mean for the sampling distribution of the sample mean. And which one of these would you do? It says, okay, now you're collecting data on students' Taco Bell spending habits. Find the mean for the distribution of the sample mean. Find the center for the distribution of the sample mean. Asha said. Does anyone see mean for distribution of sample mean on here? Does anyone see on this sheet where it says mean for distribution of sample mean? This is knowing your notation now. And check out yesterday's lecture where I go more in depth and go through all of this. I'll link that again here. Does anyone see mean for distribution of sample mean? Does anyone see that? Like, tell me in the chat where that's at. And I'm linking here, more in depth. It says more info, and there it is. Mean for distribution of sample mean. Do you see it? Mean for distribution of sample mean right there. It's the first one in the mean formulas, right? Yeah, exactly. I think that's what you're saying. No, it's this right here. Boom. So you maybe thought I was switching to proportions right now. It still means. I was still giving you a means one. Now here's a tougher one. I'm going to write it out fully. I'm going to write this out fully here for you. I'll start one more poll. UT wants to find the mean for what is expected in samples of students for in-state, if they are in-state. Samples of students measuring if they're in-state. Okay, I only have so many words. It's a little shorter. And here is the question written out. I'll repeat it. It says, UT wants to find the mean for what is expected in samples of students measuring if they're in-state. They're asking, are you in-state or out-of-state? So asking, are you in-state or out-of-state? And Aiden, great answer right there in the chat. Aiden has that. I'm very happy with the results so far. People are pretty much pulling with the right answer. Because in-state, out-of-state is a what question? Are you in-state or out-of-state is a what question? Are you in-state or out-of-state is a what question? Because this is how you know which one to do. This is what we're going over. It's categorical. Great job, Noel, right there. So that's proportions. The proportion of people who are in-state, out-of-state. You bought with the cats in the chat. So it's proportions because category. Noah is just, we're throwing 2,000 points. Give W's for Noah. Literally giving the answers I would give right here. Proportions because it's categorical. You say, wait, Brian, you said what? Find the mean. Yes. The mean, which is what is expected when we take a sample proportion. So although we're saying mean right here, we can have an expected sample proportion, which would be the true proportion. The expected sample proportion is the true proportion. And once again, check out the reviews over these, check out the chapters. This is a tough chapter. It takes a good bit of review. Going back to the leaderboard, I feel like Noah's up there. Aquatic Panda, Hero Jaguar, Excited Eagle, Shining Wombat, and Inspired Bobcat. Next question. When trying jelly beans, what is the sample space of good and bad jelly beans if you take 2 jelly beans? The sample space is the list of all possible outcomes, which includes the permutations and ordering of those outcomes. So a sample space is going to include all possible outcomes and also includes the ways in which they could occur, with the order being relevant. So make sure to include the ordering, which shows like what could occur first or second. And once again, we're just repeating the sample space is the list of all possible outcomes. The sample frame is all things you have access to, like the box of jelly beans you're eating from when you try 2 jelly beans. That's a sample frame, but the sample space is going to be all possible outcomes. And really good job. If we get it right, I usually don't go into too much detail. This is chapter 12 question. Next question, let's do it. Aquatic Panda, so excited. I could delete you though. I won't, I promise. What 3 values will you have to write interpretations for on the test worth 12 points? And you should know these. I'm going to even pull it up here and we're going to go over this. Can I find the formula sheet online? You can. I'm going to drop it here. Mubot's going to drop it in the chat. It can be found under the Stat 201 review page. Mubot's going to link you here in a second on that. So what are the 3 interpretations you need to know? And we're going to do them coming up here next. So what are the 3 interpretations? 3 interpretations. So Mubot just put, so Baylor, thank you for asking. Pretty good work. Nice job, Elizabeth. Memorize the interpretations. So R squared, slope, and intercept. QQ straight enough, no outliers, plot doesn't thicken are the 4 conditions to see if a regression is valid. QQ means you have 2 quantitative variables like height and weight. Straight enough means that a line is a good idea to fit to the relationship. No outliers means what it says, there's no outliers. And plot doesn't thicken means the points have about the same relative spread throughout the data. RMSE is root mean square, not covered in this class. Standard errors are kind of covered. Variance inflation factor, not really covered. Multiplication, addition, and complement rule are used in probability, but R squared, slope, and intercept. So let's put a little SpongeBob on the screen and let's make a regression. This is 12 points of the test. 12 points of the test. So I beg this of you. I'm going to open my Pokemon data. 12 points. I'm going to make a model predicting right now and try to interpret these to get the memory. Don't just read what people write. If you're watching this in the future, if you're here right now, even if you have to write out what someone wrote out, you're practicing writing what you're going to do for the test. So even if you're just copying for here, don't copy elsewhere. But you'll get practice of doing this. So let's predict the attack power of a Pokemon from the hit points a Pokemon has. There it is. Oh my gosh. There's big whats for this. This would have problems because this model has big whats. For my QQ, passes quantitative. Straight enough. Me. Big whats for this. Ooh, those outliers. Ooh, we could go over here and go to rows, go to colors, say a bad right there, and go to rows, go to markers, and say, uh-oh. We got those uh-oh points over there. We'll fit the line, which is what regression does. Great job with those outliers, and here we are. Before we interpret, what is the slope? Before we interpret, what is the slope? As Ren Hoek said, what is it, man? Or woman? Or pal? What is it? What is the slope? What is the slope? Where is it? What is it? What is the slope? As I'm doing this right here, tell me what is the slope? So we'll check. Be typing what is the slope in the chat. Maybe we'll take a vote. Okay, I'm going to add it to a vote. So get ready to vote on this right here. We're going to take a poll on what is the slope. Which of these is the slope? Take a vote right now in the chat. See if you know. Which one is it? The regression equation is y hat equals b0 plus b1x. Wherein, good answers in the chat, b1 is the coefficient of the slope because for each 1 unit increase in x, we expect y to increase by b1 units. Well, Mubot even put the interpretation of the slope in the chat, and you can see there is the slope coefficient, which is found also down here as the estimate of the slope. I didn't round it down there. And so now you have to think about how to interpret the slope. What is the interpretation of the slope? Type it out. Go ahead and give me some interpretation of the slope in the chat. It is, we like to call it and so I'll expand on this. Jasmine, really good question, Jasmine. Let's throw some points out there. We do it this way to write y hat equals b0 plus b1x1 plus b2x2. So if we have more x's, we start calling it like b1, b2, b3. We could do that. And what you said right there with this being y equals mx plus b, it's the same equation, just slightly different notation because we're being unique because we do stats. It is the classic y equals, and this would be the mx right here, and this would be the plus b. So the b itself, the b0, is the intercept, which can be found down here on the model. So that's the b, and that's the b0. And then the slope coefficient is the m right there, and that's the rise over run of the model. And you can see right there, and the name of the x is the name of the x variable. So whatever the x is right there is the x, and the name of the y is going to be the name of the y. Whatever the y is named is going to be the name of the y. And that means predicted y, which is the line itself. So the line itself is the line of prediction. And so I hope the highlighting here helps you understand, and I see lots of great answers in the chat. So if you notice the chat, just try writing it out. And we have here, for each 1 unit increase in hit points, we expect attack to increase by 0.54. And throw a little on average right there. They like a little Salt Bay. Why does he drop it over his elbow? I said, can you just like do this thing? I don't need the elbow. I don't need your elbow, Salt. Sorry, Salt Bay. I don't even need your $500 steak. Tomahawk steak. No. So with this right here, great interpretations. For each 1 unit increase in HP, we expect the attack power of a Pokemon to increase by 0.54 on average. Did Mubot say on average? I hope he did. Yeah, he did say on average. How about that intercept? I'm going to pin Mubot's comment with the intercept right here. So take a look. MuBot's going to tell you how to say the intercept for practice. You also want to comment if it's logical. And this one's a bit of a weird one because think about what it means. So this is hit points, which is how many hit points, like how many hits the Pokemon take before it faints. They don't get beat up, they faint. So how many hit points it has. So MuBot's got the pinned comment right there. So how would you interpret the intercept? How would you interpret the intercept? How would you interpret the intercept? You have to plug in. And so is that logical, Aiden? And so no, you have what is the intercept. If it says interpret the intercept, you got to write the full sentence. Very common mistake on the test, which I tell my graders give like half a point, is if people just give the intercept. We don't want you to just find it. So is this, Aiden's right, it's not logical. So you'd have to add on to it. So be typing out, ooh, Drew, I think has it. Yes, Drew right here. When HP is equal to 0, we expect attack to equal 41.8. This is not logical because if HP is 0, the Pokemon cannot attack, which it can't have a hit points of 0. So when HP is equal to 0, we expect, and so Andrew right there, here's a big thing. The expect is kind of key, because it's a prediction. So not that we know attack will be this, the expect right there, while it seems like just one extra word, is very important because it's a prediction from the model. If you notice, within this area I'm circling, right here, for that X is the expected or predicted, yet there's variation around it because it's not that everything has it. Good work, Andrew, right there. The expect is actually a key word. You could say predicted. You could say when a Pokemon's hit points is 0, we predict its attack power to be 41.8. Does that make sense? Will this be converted? It will be, Blake. Good to see you there, Blake. This will be completely viewable afterwards and good practice. Cora wrote, when hit points is equal to 0, we expect the attack power to equal 41.8. This is not logical because hit points cannot be 0 and there still be an attack at the same time. Boom. Great answer right there. Would you get points off if you don't include on the on average part for the slope? I don't like it when the graders take off points for that, but I have seen some do it. That's why I safeguard your grade. I tell my graders not to do it, but sometimes they do, even though I say don't do it. And we had to do some regrading. So if you feel like you've been unfairly graded, talk to your instructor. If you're like, I think the grading was harsh, a lot of instructors are usually willing, I mean, not that they are all willing to look it over, but they might be willing to give points back. They're willing to look it over. They might be willing to give points back. You never know unless you ask. Now, here's the thing. Before we do R squared, I want everyone to scream at the top of their lungs. R squared is not R. B0 is the intercept. Marley, good questions. R squared is not R. What is R squared not? R squared is not R. R squared is not R. Aiden's doing it. We're throwing some points out there. R squared is not R. I was going to scream it, and people are going to be really scared. In my younger years, I would have screamed it. R squared is not R. It's not. It's the amount of variation in Y explained by X. And so if you notice, MuBot's going crazy telling you what R squared is right there. It's a percent of variation in Y explained by the variation in X. Do it, I dare you. R squared is not R! I'm okay. So, just for the memes. So R squared is not R. So go ahead and interpret it. How do you interpret R squared? How do you interpret it? It's your turn now to interpret it. So go ahead and try to interpret R squared, which is not R. How do you interpret it? How do you interpret it? Remember, it's not correlation. Don't talk about correlation or fit of the model. I've kind of released that a little bit. 17.84% of the variation in attack is explained by the variation in horsepower in hit points. There's a card data set, which HP for horsepower. 17% of the variation in attack is explained by the variation in HP. There you go. Hit points can explain 17%. Close, Blake. Good answers right there. Some graders will give you good points for that. I always try to safeguard as many points as I can get for you. So if you notice what MuBot has right here, you basically plug and chug into the interpretation. People say, do I have to write it that way? No, you don't have to. But the more you break the structure, you could lose an important part like the expected, or maybe not go into enough detail. It deals with technically the reduction in the sums of squared error in the Y variable due to the predictive power of the model. And Pikachu has crazy high horsepower. He does. I think that's in an episode. So 17% or 17.84% of the variation in attack can be explained by the variation in hit points or Pikachu's horsepower. That's 12 points of the test. 12 points of the test. So practice it, know it, put it on note cards, and look at it. Leaderboard time: Aquatic Panda, Hero Jaguar, Amazing Duck, Inspired Bobcat, and Speedy Sloth. Speeding up to leaderboard with those pancakes on your head. It's a weird hat. What is the interpretation of the slope? Who can write it out in the chat? All you have to do is click here to get the points, but who can write it out? For each 1 unit increase in X, we expect Y to increase by B1. Wait a minute, do you notice it? As you're memorizing it right now, and I'm repeating it, for each 1 unit increase in X, we expect Y to increase by B1 on average. What do you notice when you say the slope interpretation? For each 1 unit increase in X, we expect Y to increase by B1 on average. Great job, Noel. 2,000 points, Noel. Everyone click there. What do you notice? You're saying 1 twice. Did everyone hear that? For each 1 unit increase in X, we expect Y to increase by B1 on average. Something tells me the intercept interpretation will have a similar format to it. Great job, Aiden, right there in Savannah. Thank you for people typing it out and practicing, because if you don't practice it, you don't even know what you got to do on the test. If you can write it out right now with it in front of you, it's good practice. Let's do the next one. Leaderboard, we'll see, because this is an easier one. Little speed up of the Kahoot for a moment. What is the intercept? Now, as you hear me say this, listen to the pattern. When X is equal to 0, we expect Y to equal B0. And then is it logical? When X is equal to 0, we expect Y to equal B0. How many times did I say 0 in that interpretation? When X is equal to 0, we expect Y to equal B0. And then is it logical? Twice. It's the same thing with the slope. For each 1 unit increase in X, we expect Y to increase or decrease by B1 on average. So when you're thinking about your interpretations, think about how to logically memorize them. It comes down to memorization and practice. Great job, Aiden, right? Ooh, Aiden's got such a good answer. Let me double check. When X is equal to 0, we expect Y to equal B0. Is it logical or not? Aiden, amazing work. I also found it helpful to draw out a graph. It helps me understand exactly. If you're wondering what Elizabeth is saying right there, think about the drawing we did. If you look at the intercept visually, notice how I have in pink right there the intercept? The intercept is literally when what? Just repeat it back to me. The intercept is the value what? The intercept, which is like 41.8, is found when what? I'm asking about that right there. The intercept, and just think about it, it's the predicted value of Y when X is equal to 0. And then the slope is the rise over run. Exactly. It's found when X is equal to 0. So when X is equal to 0, we expect Y to equal this. Remember, it's expect or predict because it's a line. And then is it logical? And you can tell that there's no Pokemon. I think there's no Pokemon. That Pokemon is not much hit power. It's probably Slickoth, something like that. I don't know. No hit. No, it has very little hit power. Good attack, though. What Pokemon is that? Lowest hit point Pokemon in the data set. Lowest hit point Pokemon. Sort is going to make a new. Lowest hit point Pokemon. I did the highest. Highest Pokemon is Blissey hit point. That makes sense. Is that it? No, that's not hit points. Shedinja? Oh, it's a ghost bug. It's got 1 hit point. And then Diglett Dig, Diglett Dig, Magikarp. Magikarp. I can't do Pokemon questions, but that's interesting. Next question, let's do it. I think R squared, right? Oh no. We decided to talk to students in dorms and talk to all students who live in Brown as a sample. What have we done? Now we're into chapter 10. We decide to talk to students who live in the dorm and talk to all students who live in Brown. All students who live in Brown. Every student is sampled. We took a wet sample of Brown. Brown Hall, good dorm. So we need definitions for each one of these. What in the world, good answers. What is a simple random sample? A simple random sample, has anyone ever seen one of those machines, the bingo machines? It is a cluster. Good work, Blake, right there. Has anyone ever seen one of those machines where you spin the machine and it's got the balls inside of it? Maybe I'm the only one. All right, Goodbye. Just go like this. You spin it. Exactly. Numbers are drawn at random, and everything has an equal and likely chance of being selected. Simple random sample. Kind of like, exactly. Is it Powerball is pretty much a simple random sample of the numbers? Noah, great answer right there. Powerball would be defined as a simple random sample of the numbers that could be a Powerball number. And you can't repeat them, so it's simple random sample without replacement. We don't get into with and without replacement so much in this class. But that's what a simple random sample is. Next week, which was not the right answer, but that's what a simple random sample is. When everything is enumerated and given the a probability of being selected that is equal. Now we have Brian is over here. And he's just hanging outside of Hodges. And I talked to every 5th student who leaves Hodges. Brian is taking a what sample of students leaving Hodges? Brian talks to every 5th student leaving Hodges. So this would be called a what sample? That is systematic. And the key to systematic is the th of it. It's called every kth observation, but systematic is when you start at a random starting point and you select every kth observation. Kth is just a placeholder for a number that exists, and you just select in and put in a distance, and you select every kth observation, technically from a random starting point, but you select every kth observation. But this is where it gets tricky now. The tougher ones for people are differentiating between these two. The two that people always get confused on every time we do the test is cluster and stratified. And I bet we even saw it in our answers. So the wrong answers here were likely people picking stratified instead of cluster. And yet, notice right there, not that bad, really good. I'll throw you some points for that. So what's the difference? Clustering is used to speed up sampling. Did everyone hear that? I almost think that's a teaching the test moment. Ooh, Elizabeth has really good answers in the chat. We'll pin that. Cluster is used to speed up sampling. Just makes getting a whole bunch easier. What is a cluster of donuts? What's a cluster of donuts? I bet you know what a cluster of donuts is. You've probably bought one. I had one. Kind of Marley. Good answers, Marley. I got all the secrets, Blake. I got all the secrets. Soundboard. What's a cluster of donuts? I bet you've had a cluster of donuts or seen one. A cluster, a whole bunch where you can get a whole bunch at once. A dozen donuts, exactly. A dozen donuts is a cluster. What's a cluster of students? Where could you find a cluster of students? See, I got to go get clusters of students. Where could you go get a cluster of students here on campus? Guys, I got to talk to students. Let me go find a cluster to talk to. A classroom. A classroom. It could kind of be major. It's just a whole bunch. I like classroom more, a class, like a class. Let me go talk to a whole bunch of students. Let me talk to a class. So HSS Lawn, that's a class. Yeah, it's kind of a cluster. Go out there and talk to all the students. So one thing you'll notice with clusters is things are randomly put into groups, randomly in groups. And here's the thing you'll always see. Census of the group done. So I always say to students, if you buy a cluster of donuts, you're going to eat all of them. You're going to eat all the donuts. That's a census on the box of donuts. So if you wanted to see if the Krispy Kreme in your town is good, would you have to go there and say to them, I need 12 random donuts. I want a simple random sample of 12 donuts. Or could you just say, give me a box? By asking them to give you a box of their donuts, you've engaged in a cluster sample, which is still random if the box is random, which it probably is. And you've just taken a whole bunch at once. Does that make sense? Rather than saying, give me 12 random donuts, you just walk in and you see a box and you say, I'll have that box of donuts. And the things have been randomly put into that box. Now, if you went the simple random route, they would literally take each donut probably and put it into a bag and be like, here's your donut 1, here's your donut 2, and say, I don't want these clustered. I just want the individual samples, not put together in a cluster that I can sample all at once. Does that make sense what a cluster is? A cluster is when things are randomly put into groups. That's kind of hard to do sometimes. Is a classroom really random assortment of students? It's iffy. That's why major is maybe not the best cluster because major isn't random. But at Krispy Kreme, a box of donuts is probably just like any other box. Does that make sense? Do you think they put all the bad donuts in one box? Probably not. But what is stratification? Stratified starts, and I think Elizabeth said it perfectly right here. Look at the pinned comment. You acknowledge the difference and sample according to those differences. So if we wanted to figure out the views of UT students on parking, and this is what stratified is. You acknowledge the difference and sample according to the differences. And we want to talk to students about parking, how would we stratify? If we want to talk to students about parking, what difference would we acknowledge between students and then make sure we sample from those groups respectively? Like we would stratify. That's what stratifying means. Is you're saying, we got these students and these students. We probably need to take a bunch of these students. Not like all of them. We're going to talk to these and get representation from them. Parking lot, you could stratify on parking lot because what parking lot, that's a good answer, Blake, right there. What parking lot someone is assigned to would probably tell you, like, people have different experiences based on the lot. People on campus and not on campus, like commuters and non-commuters. Do you think commuters and non-commuters have different experiences with parking? People with cars and without cars? Like, what do you think of parking? So this is where you're stratifying. If we're going to do a poll about this election, and we're going to be doing a really good poll that gets a representative view, how might you stratify about this election? So you want to make sure you poll for this election and stratify. What might be some of the key things to stratify on, which people do. They make sure they have representation from each group. How much you stratify to make sure you get a proper sample, which doesn't mean you're going to take everyone from these groups. You're just making sure I get enough of these people and enough of these people. How much you stratify. And that's what strata is. It's layers and rocks. So it's separating and acknowledging differences. Strata does mean layers in Latin. Or stratum in the stratosphere and things like that. Stratum and dirt. With the election, how might you stratify? They do it. If you look at how polling is done, they stratify to make sure that when you poll, it might not be even from each group. It might not be even, though. You would look at historic history and say, young people don't vote as much. So in the 18 to 25 group, you might have 10% of your sample because they might make up 10% historically in elections. So if you take a sample of people and you sample 1,000 people, you might take 10% from that group. Republican or Democrat or independent. If you only talk to Republicans, you undercover Democrats. Another key term. If you only talk to Democrats, you undercover Republicans and other groups too. So you might stratify and say, we need to make sure that 48% is Republican, 48% is Democrat, and 4% are unaffiliated. I don't know what the numbers are. You look at the historic data to figure out what your sample would look like. Stratification starts with acknowledging differences and then making sure you sample in accordance to those differences. What do you think makes sampling harder, clustering or stratified? What makes sampling harder and more time consuming? Which doesn't mean bad. It just means, what do you think makes it harder, stratified or clustering? What do you think makes it harder? Can you give two questions you can use to distinguish and stratify and cluster? Yeah, I'll do that next year. We'll do that, and then we'll go back to the Kahoot. Stratifying makes it harder. You have to take more time. Stratifying is making sure you're guarding against undercovering and you're getting representation so that you have that's what we do. We do representative samples. You're making sure your sample accurately gives the population the right sort of view. So stratification is about making sure you get the right amounts of each in your sample. Clustering just speeds up the process when things are randomly put together. So Brian has been tasked with finding out students' views on technology and classrooms. Brian goes to each major in the Haslam College of Business and talks to 5% of the students in that major for his sample. Don't answer in the chat. And so what did Brian do? I'm going to give you a poll. Okay. So what did Brian do? Brian is tasked with finding out the views of students on technology enhanced education. He talks to 5% of the students within each major. So he goes to business analytics, he goes to marketing, he goes to all the different majors and talks to 5% of the students in each major. Very clearly, I have done what? Think about the definitions we've already talked about. Very clearly, I'm doing what? Anyone give some keywords and I'll explain the full answer. Just think through it like very clearly. I've started by doing what? Pretty good answers in the chat too. So what I'm doing is, so what does each major imply right there? So what does each major imply? Everyone's saying each. What does that imply? There's a pin definition. Good answers, David and Blake. I'll answer in about 10 seconds here. Travis, we'll throw you some points right there. Acknowledging differences between the majors. And I'm avoiding, yes, Aiden, right there, I'm avoiding undercoverage because it's really, I talked to too many business analytics majors. No. We're representatively sampling each major and not undercovering and making sure we get enough of each that we give a proper representative view. Now, if I were to talk to, let's say, classrooms, so I could add a cluster element to this. To do this, he goes to classrooms for each major and samples everyone in the class. This is now a multi-stage where we have classrooms taken our clusters, majors are the stratification. Does that make sense? So since I'm taking classrooms of students, the classrooms of students are the clusters, because I'm going to go and I'm going to talk to all the students in the classrooms because I sample everyone. Notice that means a census was done on the classroom. So the classroom is the cluster and the majors are the stratification because that's where I'm acknowledging the differences. So we stratified on major and we cluster sampled classrooms. So a lot of people get confused because they both deal with groups, but clustering just means you're taking a whole bunch at once and sampling everything within that, where stratification means you're acknowledging differences and making sure you sample according to those differences. So really good review of the topic. I hope that helps. Check out the lectures and the speed runs. If you didn't know we got speed runs over this, here we go with the next leaderboard. Aquatic Panda, Inspired Bobcat, Amazing Duck, Hero Jaguar, and Speedy Sloth. No worries, Blake. Also, for the first time joining the study session, what are the points for towards Kahoots? It's for, you don't know this, but...
I am Ubot. I give out the points for Brian's class. This is how he does bonus, and I control it. I was out for a little bit, and then Brian made another Mubot. Don't do that, Brian.
We didn't make another Mubot. Oh, you can't even see him. Oh, there he is. Sorry about that, Mubot. He's a little salty about that. How rude. This is some full house right there. Next question. What is the best way to know the difference between p hat, y bar, and p and mu? We're talking literally the difference between p and p hat. This is a notation question. It's a rather tough one. If you get this one, good for you. If you don't, it's probably due to my inability to write good questions. No test question looks exactly like this, but you're meant to know what is p hat. P hat means sample proportion, found by x over n. That scared me. X over n means the number of successes over the numbers of trials. That is what p hat is. Y bar is sample mean, which means if I talk to 50 students and they eat on average $8 of Taco Bell, that's the sample mean from 50 students. And don't worry, I do think this is a bit of an unfair question. Sorry if I broke anyone's streak. But it says, what is the difference between p and p hat? So P and P hat, P is for the population, which is when UT knows 60% of students are in state. P hat is for a sample. So P hat and Y bar come from samples. There's a lot of other true statements on here. So this is a true statement. P hat is for proportions and Y bar is for means. But up here I wrote, what's the difference between P and P hat? This is truth for populations. This here is for samples, like p hat with respect to p, y bar with respect to mu. No question looks like this. What should you know from this? You need to know what?
Notation, brother.
What do you need to know from this? What do you need to know? I think I'm hitting the right button.
Notation, brother.
P hat is sample proportion. Good question, Blake, right there. Let's write these down. Actually, we've got chapter 10 notes. I'm going to show them here on the screen. Chapter 10 notes coming up in just a second. And really good. This is a big review study session. I feel like we've lost a few people here. Where's my people at? We're pulling up the notes right here. And I'm going to show you the notation on this. We actually have the notes here. Here we go. Chapter 10, sample surveys. That's the old one. Okay. Little quick review on this. Here's the sheet. Let's go check it out. So if you see right here, I'll get the screen looking a little better. The way to use this if you go right here, statistics are for samples. You're welcome, Blake. I appreciate that. Statistics are for samples. So you have sample, statistics, and population parameters. Very good to know right there. Populations have parameters which are truths, as in when the election day, moo right there, when election day happens, we would know the true proportion of people who vote for a candidate. Right now, we only know the sample proportion right there. Does that make sense? When we take polls, we get sample proportions. So if somebody says to you, what is Y bar? Y bar is the what? Y bar is known as the what? What is Y bar? Y bar is the what? It is a statistic, but I'm looking for more. Y bar is what? Like you talk to 50 students and they eat $8 of Taco Bell on average. I just told you a what? Sample mean. Great job, Noah. Y bar is the mean of the sample. That is true right there, Blake, too. The mean of the sample. So Y bar is the mean of the sample, which is a statistic. And then if Taco Bell says we have recorded data on students and we know how much Taco Bell they eat on average, and so Taco Bell says we know how much students eat on average, like money-wise, Taco Bell would know what? Which you'd say, how do they know that? I don't know, it's a made-up example. Taco Bell says we know the truth for what students eat dollar-wise on average. Taco Bell says they know the truth because students scan their card or something, and they can say, here's the actual full data set. So they would know what? What would Taco Bell know? If they know for everybody, like the truth for all students, what they eat on average. The population mean, exactly. Great job, Noel, right there. The population mean. If you go across right here, you'll notice you go to that right there, the population mean. So that is mu. And so sample proportion would be if Taco Bell says something like, we talked to 50 people who came in, and of the 50 people, 30 were students, which would find p hat equals x over n, which there were 30 students out of the 50. The sample proportion is this. And then if Taco Bell said, we know that 55% of our customers are students, that's a statement of fact where they're saying we know 55% are students. So p hat comes from a sample, which we talked to 50 people and 30 were students. That's a p hat. Versus a statement of fact, we know 55% are students out of everybody who visits our restaurant. Does that make sense right here, where one is a statement of fact? Good to see you, Ohm, in the chat. Right here, statement of fact would be P right there. P is the statement of fact for the population, and a statement of the proportion, which is a categorical idea. With that, let's head back. It's all about that
Notation,
brother. Here we go with the leaderboard: Aquatic Panda, Excited Eagle, Shining Wombat, Inspired Bobcat, and Amazing Duck. Let's do it. The central limit theorem is fundamental to statistics. Wait, what? The central limit theorem is fundamental to statistics. It's not like this is a teaching to the test moment and I'm blocking the answer. It's not the Pythagorean theorem. It's not. A squared plus b squared equals c squared. Really cool stuff. It is not that states that less likely events are more likely to occur in the future. That is the law of averages, which is a fallacy, improper way of thinking. States over the long run of repeated trials, we see the true probability for 1,000 points. What is that? That states if we have something and we observe it, which a lot of people put that one, that is a fact. But that is not the central limit theorem. The central limit theorem is fundamental to statistics, and the law of large number, great job, Lars, right there. The law of large numbers states that over repeated trials, you will see the true probability of an event. Why does the central limit theorem matter, and why don't you remember it? Well, we just taught it last class in our class. The central limit theorem states two things. Good answers, Blake, right there. Let's throw some big points out. The central limit theorem states that the distribution will become more normal and tighter as n increases. Here is an n of 2, and we mean the distribution of sample means. Here's an n of 2, notice it's tighter. Here's an n of 16, notice it's tighter. Here's an n of 25, notice it's tighter. Now, this is normal down below because the top is normal. But if we were to have a very skewed distribution, notice right now we would not meet condition 3 for sample means where n is large enough. Taking two observations and taking the average for the distribution of sample means can be seen below. And if you repeat this process, you'll build up into a distribution that's still skewed because n was not large enough. Random, 10%, and large enough n. check out the videos where I go over this to understand what the large enough n condition is and how you have to look at the shape and know the amount of sample you need based on the shape of the original parent population. But notice as n increases, it becomes more normal and tighter. Frankly, it's almost normal there. And this is because we're dividing by the square root of n for the standard deviation. It's a lot to take in right now. But what are two key facts about the central limit theorem? It states that the distribution will become more water and get more water. So you can see both of them right here because n got very large. It got more water and it got more water. The central limit theorem states as n increases, which is this is fundamental to statistics. As n increases, the sample size increases, it'll get more normal and tighter. And I want you to think, why is it fundamental? Do you know why it's fundamental? Because 68, 95, 99.7, now we can use the normal curve. So it's fundamental, and great job, Blake, right there. It's fundamental because we can use the normal curve. We can describe this. We can do probabilities. So without the central limit theorem, we wouldn't know it's normal. And if we don't know it's normal, then 68, 95, it doesn't matter. We can't do that stuff. You can't do 68, 95, 99.7 up there. 68, 95, 99.7. You can't do it up there, but you can down here. So it's fundamental because we can use things like the empirical rule, and that's why we love the central limit theorem, and it's fundamental to statistics. Leaderboard time. Excited Eagle. Man, when the Red Bull kicks in, or not Red Bull, Monster kicks in, you know it. Sorry. Inspired Bobcat, Amazing Duck, Hero Jaguar, Aquatic Panda. Let's do this. The conditions for the sampling distribution of the sample proportion are what? Now, the first thing you learn for conditions are for regression. This is not regression, but regression is QQ, straight enough, no outliers, plot doesn't thicken. Make sure to know those. QQ meaning two quantitative variables. Straight enough meaning a straight line well describes it. No outliers means no outliers. And then plot doesn't thicken means about the same strength. And great job, Blake, in the chat. Because the first two conditions for the remainder of the semester will be random 10%. And then you have to pause and really good work. Amazing work in the chat. Remember, it's less than 10%. Aiden with those advice right there. It's not more than 10%. The 10% condition is less than 10%, which is kind of counterintuitive. On Tuesday's class, we went into great detail on why we say less than 10%. So here's the thing. The third condition for the remainder of the semester will change. And although we are doing test 2 right now, I want you to understand that when you get to the third condition, you will always put them into the chat for me. You will always do what when you get to the third condition? When you get to the third condition, you will always do what? What will you do when you get to the third condition? You will always what? Put them in the chat. You'll pause. Put those pause in the chat. Because for the remainder of the semester, as best you can read with my horrible handwriting and Brian from 5-6 years ago, you will pause. Go Cards. So the next conditions follow based on what kind of data you're working with. Success failures for categorical data. We will call the large enough n nearly normal later on. For right now, nearly normal encompasses the large enough n condition, but the means will use what we call large enough n. That's for later. Chi-squared is its own sort of beast, which has expected cell count and count data. There is sometimes a fourth condition. That's for test 3. But notice what we're learning right now is aside from regression, condition 1, random. Condition 2, 10%, less than 10% of the population sampled. Pause and then say, am I working with categorical or quantitative data? And because we're dealing with proportions, yes, exactly. Ooh, Blake's got really good. Blake, you don't know the size of the, wow. Everyone put some W Blake in the chat right there. That is the theoretical exact answer for why on exam 3 we do not use large enough n, because we do not know population size. You could kind of theoretically go off of that idea and you could make assumptions, but the population size is not, because sampling distributions deals with we know a population the N, the capital N of the population. But then when we switch over to nearly normal deals more with the central limit theorem and looking at the shape of the distribution and is it nearly normal using things like goodness of fit test, Shapiro-Wilk test, or just looking at the histogram. So it gets a little bit easier to do that. And we're just large enough N and nearly normal.
It doesn't matter. It
It's the same sort of thing. I get mad when a test question is like, no, it's large enough N. No, it's nearly normal. Large enough N means large enough sample size such that the parent population will have a nearly normal shape. See, I said nearly normal. I don't know. Does it matter? Kinda. So on this test, the conditions for, let me repeat this if you're taking notes. If you're doing regression, QQ straight enough, no outliers, plot doesn't thicken. If you're doing sampling distribution of sample proportion, random 10% success failure. If you're doing sampling distribution of sample mean, random 10% large enough N. I've got videos going over those. Leaderboard time, inspired bobcat, excited eagle, amazing duck, hero jaguar, and aquatic panda. Let's do it. The large enough N states what? Ooh, who knows? I said we'd be done at 1:30. We'll get done closer to 2. Sorry, I think might have to run. Might do a little fast. So the first thing we would do is we'd look at the shape of the population. And we'd see, based on the shape, how large of a sample we need to take. Now be careful. How large of a sample we need to take is what in notation? This is where people probably made a mistake. What is the sample size in notation? If you made this mistake, don't worry. This is sample size. And it would be the less normal a distribution is, the larger N needs to be. I'll show you. Let's go over here to the central limit applet again. Let me ask you this. Is a sample size of 2 large enough such that this distribution down here will be normal? Yes or no? See, Elizabeth, and this is recorded so you can check it out later. Thank you so much. Is a sample size of 2 large enough? We'll throw Elizabeth some points. So the steps are, look at the shape of the parent population. If it's normal, you need a sample size of at least 1. If it's skewed, you need 25. If it's very skewed, you need 100. So it's normal. How much sample size do I need? Remember, I'll repeat it again. You look at the shape of the data, or the question tells you the shape. If it's normal, you need 1. If it's skewed, you need 25. If it's very skewed, you need 100. So is 2 large enough? Well, it's normal. So I need a sample size of what? Tell me in the chat. Tell me answers in the chat. It's normal, so I need a sample size of what? This is normal, so I need a sample size of... The more skewed it is, i.e. the less normal, the larger N needs to be. So since this is normal, I need 1. Do I have at least 1? Well, you always have at least 1, because if you're doing averages, you'd have 1, just the observations to begin with. I have 2. So the answer is, this will be normal. And think about it. This distribution will be more normal. Wait a minute, this is already normal, and this is more normal, so if it's normal, it'll still be normal. Does that make sense? Remember the central limit theorem states that the distribution will become more normal? Well, it's already normal. So if it's already normal, this will be normal. So what about if it was it's skewed? We'll just say skewed. If it's skewed, I need a sample size of at least what? Remember, if it's normal, you only need 1. If it's skewed, 25. If it's very skewed, 100. So now I need 25. So type yes or no with only a sample size of 2. Will the distributions of means of sample size 2 be normal? Will the distributions of means of sample size 2? Wow, that was interesting. See, that was all the way at the end of the distribution. No, because we do not have a large enough sample size for the central limit theorem to kick in, which is fundamental to statistics. So we want to be able to use the normal techniques to describe this. And right now, a sample size of 2 is not a large enough N. I don't like it does capital N. It should be lowercase n technically. Now watch when I go to 25, all of a sudden now, sampling 25 observations and taking the mean is going to pull it more towards the middle. It's going to be, I thought it'd be a little farther over. But still, these will start to land in the same spot because we're reducing the variation, because they're averaging together. Every blue dot is the average of 25, making this the distributions of means of sample size 25. And then I'm repeating the process a whole bunch of times, speeding it up till we get this, the central limit theorem. Now we see a distribution that is tighter and more normal, and N was large enough such that it's normal. So when you look at the answer right here, The question being, if the large enough n states right here, the less normal a distribution is, the larger n needs to be. And look up here, you see where it says n? A lot of people caught up on that. So the less normal the distribution is, the larger of a sample you need for the central limit theorem to kick in. This was a less normal, larger n. This was a normal, you don't need a large n because the distribution will be normal down below. So that's what the large enough n states for quantitative data. Leaderboard time, Aquatic Panda Inspire. Ooh, Aquatic's starting to, no, it's a close game. Anyone's game. Next question. How do we check the 10% condition? So what mathematical formula will check the 10% condition? What do? The 10% condition states that, oh good, I'm not blocking the right answer. The 10% condition states that our sample needs to be less than 10% of the population. I'm going to give you a question in the chat, and I want you to tell me if we got it right. We talk to okay. Here's a question in the chat. We talked to 100 UT students, and 50 of them like Taco Bell. Do we pass the 10% condition? Does the central limit theorem, CLT, apply to law of averages and law of large numbers and law of averages? I might be confused. The central limit theorem is just a statement of fact about the shape of a distribution. When it comes to sampling larger amounts, it works a lot with the t and the normal, such that the shape, and so this is what the central limit theorem states, is that the shape of a distribution will become more normal and tighter when we take larger amounts of observations and look at the distribution of means for larger observations. So does it apply to law of averages is a fallacy, which is false. So law of averages, we would say, is not something true in statistics. And law of large numbers could apply because for larger amounts, you're going to see the true probability. So the variation among the truth in samples, you could connect it to law of large numbers. You could talk about how they connect. Like I could probably write you a paper on that. It does apply in a sense. That's a deep, deep knowledge right there. So be careful here. In this problem I wrote to you, what should you do? So let me grab this thing and double check. What do you need to know to solve things on this test?
Notation, brother.
If you get a question asking you about the 10% condition, what should you do? And I want you to see half of everyone's divided on this. What do you need to do for questions? You get a question about the 10% condition, what do you do?
Notation,
what do you
brother.
need to do? What do you need to do? We talked to 100 UT students, 50 of them like Taco Bell. Do we pass the 10% condition? What do you need to do? Leo knows. I met Leo.
Notation, brother.
It's not Leo, but he would say notation, brother. So you need to know the notation. What is this? What is this right there? What are those? Lars, 1,000 points. Lars has answered the question. I can see Lars knows the answer. So Lars is correct. Lars has done the right work. So what are those things? What is 100? What is 50? What can we find from them? So knowing your notation is key. What is 100? What is 50? And thank you, everybody. I know we're doing a big Kahoot right here because we've put a lot of mini lectures in this. You have to know the notation. Take notes on this. Be like, I have to know. If you see me write a notation, write it down with an example. So what is 100? What is 50? Any guesses? We talked to 100 students, so that's obviously my what? I talked to 100 students. Sigma stands for standard deviation. So sigma is the standard deviation. Great job, Aiden. Good guesses, everybody. So this is going to be the sample size, and this is the amount of successes. So what do we find from this? Very close call right there. P hat, basically, but we'll do it as a decimal, is going to be 50 over 100, and you would say 50% of my sample liked Taco Bell. Does that make sense? So 50% of my sample liked Taco Bell. To check to see if we meet the 10% condition, we ask n over capital N is less than or equal to 10%. So you'd have to say, I talked to 100 students out of the 35,000 UT students. So is 100 students less than 10% of all UT students? Taco Bell is facts. Taco Bell is amazing. 100 is the sample size, yes. Capital N was not given in this problem. Capital N was not given. You have to think, 100 students less than 10% of all UT students, and great job, Katie, right there, and Thomas and Tommy and Noah and David and Noel. It is true that 100 students is less than 10% of all UT students. You were not given capital N. Sometimes you have to think about it a little bit. We often do that for very large population sizes. So capital N represents population size. I'll show that one more time right here, and I'll just hover over it, or I'll highlight it. Capital N is size of population. Lowercase n is size of sample. X stands for amount of successes or conforming observations to what you wish to observe. So you can see right here throughout the formulas, which is used to find p hat via the formula x over n. So make sure to know the notation.
Notation,
know the notation. So good stuff. Here we go. Another question, but leaderboard Tom. Aquatic Panda, Excited Eagle, Speedy Sloth, Funny Cat, Hero Jaguar. How do we check the success failure condition? What do we do? Success failure condition is checked how? What do we do? There is a very simple formula. And think about this. If I am told that 60% of students are in state, and I talk to 10 students, how many would I expect to be in state? If you answer that question, you actually know how to check this. I am told 60% of students are in state. I talk to 10 students. How many would I expect to be in state? Good work. Pretty good work. I talked to 10 students and I know, great job, Marley. You are correct. You actually just solved it. Let's look at what I told you. So to check the success failure condition, you need at least 10 successes, at least 10 failures. Another teaching to the test moment brought to you by me, Brian Stevens. But it doesn't state it needs to be binary. Although you could argue, but isn't it binary? That's not what the condition states. The condition states we need at least 10 successes, at least 10 failures. So what do you mean? Well, I go and talk to 10, not that. I go and talk to 10 students, and 60% of them are in state. From the registrar, we are told this. Since the registrar has told this, this is a statement of fact. I'm not saying 60% of my sample is in state. I'm saying I would expect NP, which is from my sample, the truth of being 60%, I would expect right here to have 6 in-state students. How many out-of-state students would I expect? And how would I figure out you're either in or out of state? What is the probability of out of state, which is not in state? So how would we figure out out of state and probability and amount of expected out of state students? How would we do that? How would we do that? Exactly, Jasmine. Great answers, Jasmine. Q equals 1 minus P. So P and Q are complements, and thus you get 1 minus 0.60, and Q is equal to 0.40. And then you can see NQ right here is equal to 10 times 0.40, which is equal to 4. So we would expect 4. Does that make sense to say 60% of students are in states? I talked to 10 students. I'd expect 6 to be in state and expect 4 to be out of state. It's not saying that's what we'll see. It's just what I expect. So this is the amount of successes and failures we expect. Successes just means conforms to what you're looking for, and failures means is not the thing you're looking for. You could flip it and just say 40% are out of state, and now that's a success. I'm out of state. I'm a New Yorker. How about if we up this to 100 or 1,000 students? Now we would expect how many students to be in state and how many students to be out of state. How many in state, how many out of state? How many in state, how many out of state students? How many in state, how many out of state students? You just got to solve it. You just do NP equals this, NQ equals this, and then you're like, oh, that makes sense. 60% of that, 40% of that. What would you expect? I just got to add some zeros. What is the value of 4 going to represent? The value of, this is the expected number of out-of-state students when talking to a sample size of 10. So let me change it back real quick. For a sample size of 10, sorry, here you notice sample size of 10, I'd expect 40 to be out of state, so I expect 4 out-of-state students. Versus a sample size of 1,000, now I would expect 600 in-state students, and for a sample size of 1,000, I expect 400 out-of-state students. Good questions, Blake. And here's the thing, though. if we don't meet the conditions, the distribution won't look what? If we don't meet the conditions, the whole point of these conditions, another teaching to the test moment, you're meeting conditions such that the central limit theorem kicks in and the distribution looks normal. If you only have 1% successes in 100 samples, you'd expect 1 success and 99 failures. Versus here, now you expect 10 successes and 90 failures. Now you expect 30 successes and 70 failures. Now you expect 99 successes and 1 failure. Notice it doesn't look normal again. So the whole point of meeting random 10% success failure, or for the other chapter, random 10% large enough n, is such that the distribution looks normal. And 50% is when it looks most normal, when it's symmetric the most. It'll look normal enough such that the central limit theorem states we can use the 68, 95, 99.7 rule and do things like z-scores. Okay, really great review. Here we go. Aquatic panda, excited eagle, speedy sloth. Next question. The success failure condition states which of the following? What does it state? Does it state your variable must be binary? It's almost like I'm giving you hints by saying, no. Let me point at this and say it again. No. Please don't answer blue. Please don't answer blue. We were just saying it a moment ago. Like there's an equation. You have to find n, sample size. You have to find p, true proportion of something or true probability of something occurring. You have to find q, the complement of p. It does not state it needs to be binary. I'll give a huge success on this. Thank you so much. We did not answer the blue answer. We did not answer the blue answer. So good work right there, everybody. Let's continue on with the next question. Aquatic panda, great job. Probability of making a shot is 30%. What is its complement? Complement, just like P and Q, is found by 1 minus the probability of an event. So 1 minus the probability. And make sure to check out review 2. If you're watching this now or in the future, review 2 has in it the ability to review and the material. But review 2 found right there in the pinned comment once Mubot says it. Come on, Mubot. Thank you, Mubot. You're always there for us. You're always there. So complement is 1 minus p, and I hope we did really well. Yes, don't worry if you got it wrong. You might have misclicked. 1 minus p is q. It's complement. You either make the shot or don't make the shot. Aquatic panda still in the lead, but a close game. Funny cat, you got this. Funny cat, funny cat. Why are you so funny, cat? The law of averages is a fallacy. The truth is what? So if you flip heads a whole bunch of times, tails is more likely to occur. No, coins don't care what you flip. They don't have feelings. Not like me. 2 disjoint events can be added together. That is a fact, but that has to deal with the addition rule right there. That's nothing to do with the law of averages. So 2 independent events can be multiplied. That's a fact too, but that has nothing to deal with this right here. The law of averages is a fallacy known as gambler's fallacy. Lars is right that independent things influence current trials. This is truth, but unrelated. And this is the law. That is the law of averages, which is a fallacy known as gambler's fallacy. I really like, man, I'll throw 2,000 or 5,000. It's a 5,000 point button. If I tell you Brian Stevens has hair, thus Brian Stevens is the smartest man alive, what fallacy have I engaged in? Brian Stevens has hair, thus Brian Stevens is the smartest man alive. Circular logic is Brian Stevens is the smartest man alive, thus Brian Stevens is the smartest man alive. I'm not the smartest man alive. It's not meant to be like, oh, look, I have hair, I'm the smartest man alive. So circular logic is when the claim itself is used as the evidence of the claim. That's a circular logic. So circularity is when you go back to, so what is it if you say like, someone says, why do you think your friend will be late? And they say, well, because they're wearing a green shirt. So slippery slope is saying like, if we give our kids a donut, they're going to be drinking soda at every meal. That's a slippery slope fallacy, which is kind of a form of this one. So slippery slope is when you imply something much greater that would not follow. This is known as a non sequitur, which is not on our test, but I really like logic and logical fallacies. It's a logical fallacy, yes. It would be called a non sequitur. It does not follow. Non sequitur means does not follow. So because Brian has hair, it does not follow that Brian would be the smartest man alive. Called it does not follow. Also, the slippery slope is a form of non sequitur. It does not follow that if you give your child a donut that they will drink soda at every meal. And the slippery slope implies that like you're going to do this, which is going to lead to this much greater thing. Premise not being true is going to be, so you can either have your premise or your conclusions. The conclusion not following is the issue here, Blake, which goes to the validity of the form of the logical syllogism. Ooh, I like logic. Enough about logic, more about stats. Let's go back to that leaderboard. Here we are with Aquatic Panda, Excited Eagle, Hero Jaguar, Speedy Sloth, Inspired Bobcat. Next question. To calculate p hat, we must meet 3 conditions, true or false. What's the formula for p hat? A lot of people get this wrong. What is the formula for p hat? Just type it in the chat. We talked about it earlier. And I want you to remember examples like this. Remember the formula for p hat. Does anyone know the formula in the chat? What's the formula? It's x over n. Great job, Ian, right there. So you walk into a room and you see 3 out of 5 people are eating Taco Bell. What's p hat? The answer is no. There's no formula, or there's no conditions for p hat. You walk into a room and 3 out of 5 people are eating Taco Bell. Great job, Jasmine. There's no conditions for it. Why do we check conditions? There's no conditions to find p hat. There's no conditions to find y bar. Let me state this in this voice. There's no conditions to find p hat. There's no conditions to find y bar. They're just found from data. There's no conditions to find p hat. There's no conditions to find y bar. The whole point of doing conditions is to see if the distribution will be what. Great job, Blake, right there. The whole point of checking conditions is to see that the distribution will have what shape. The whole point of checking conditions is to see if it's normal. So yes or no, do we use conditions to find p hat? Do we use conditions to find y bar? Sample proportion, sample mean. Do we use conditions to find those things? Do we like, man, I don't pass my conditions. I can't find p hat. No! 2 of your 8 friends own bunnies. What's p hat? 2 of your 8 friends own bunnies. What's p hat? My wife and I are your friends. We own bunnies. While you ponder that, no one knows what p hat is? 2 of your 8 friends own bunnies. P hat stands for sample proportion. Drew got it. Great job right there. It's just 2 over 8. 25% of my friends own bunnies. The more you can come up with your own examples where you know the notation, the better. Did everyone hear that? Think up your own examples where you could come up with what is an X. An X here meaning, thank you there, Marley. X meaning number of successes, 8 meaning the sample size of which you took. If you can come up with your own examples where you come up with an X, an N, find a P hat, you can come up where you state what a P is, would you state what a mu is, what a Y bar, what a sigma, what an S is, all these different things right here. Check out the formula sheets from yesterday. That's going to help you remember what these concepts are. When you get to the test, you'll be like, oh, that's P right there, because it's saying 10% of America owns bunnies, which is a statement of fact, not from a sample. Here we go with the full screening and the leaderboard. Hero Jaguar. We have a new leader, Hero Jaguar in the lead. Let's continue on. Good job, Hero Jaguar. We know 20% of UT is freshmen. We sampled 200 students and 30 report being freshmen. What is P? We know 20% of UT is freshmen. We sample. So can anyone tell me what P stands for? What is P in terms of words? More Morty content? I'll find another Morty picture on the computer. We'll end with a Morty picture. I'll get the picture of him driving his car. He has a little car that he used to drive. The population proportion. So stay till the end. You'll get to see Morty driving a car. P stands for the population proportion. And here it would be 20%. Because it's a statement of fact. We know 20% of UT is freshmen. Like of faculty, freshmen, sophomores, staff, everybody here at UT. 20% are freshmen. Statement of fact. What is 200? We sample 200. So what is 200 in notation? What is 200 in notation? Just follow through with me and try to solve everything here. 200 is known as what in this problem? Sample size n. What is 30? 30 is how many report being freshmen in our sample. So 200 is n. What is 30? 30 is how many were freshmen in our sample. 30 is x, the amount of successes in the sample. 30 is x. You take x over n and you find p hat right there. So that is sample proportion. So that is from my sample, which would be p hat. So p hat, second most wrong answer right there, is 0.15. Now here's a harder question, which we will do a few more of these, and get your calculator because there's going to be a little math calculation. What is mu p hat for this problem? And I bet someone could get it like that. For this problem, what is mu p hat? What is mu p hat? You're like, oh, I got to find mu p hat? That's going to be really tough. Does anyone know? Who can tell me what mu p hat is? Aiden got it in seconds. Because mu p hat is equal to p. So you remember when you just found what p is equal to? Well, mu p hat is p. Because we would expect to see 20% freshmen if UT is 20% freshman. And that's how that reads. I would expect in a sample 20% freshmen, given the fact that UT is 20% freshman. If students spend on average $8 at Taco Bell, because this is quantitative, I'd expect, I like to say expected sometimes for mu right there, mind blowing, like just wow.
Wow.
So I would expect a sample mean of $8 if the true mean is $8. I'm just coming up with those numbers for an example. Like students truly spend $8 at Taco Bell. Well, in a sample, I'd expect $8. So those questions usually just stump people, but it's knowing the wording and practicing. So this tough chapter, chapter 13. Let's do another one. Here we go. Aquatic Panda. It's all out. Who knows who's going to win? Remember, Kahoot t-shirts for winners. Let me announce this here again. If you win, email me from your UTK email. State whether you want a Starbucks or Amazon gift card. So be like, hey, Brian, I won. Here's a picture. As long as 10 people don't email me. No one's ever done that. Tell me you won. Send me a picture if you can. And state Starbucks or Amazon, $20 gift card. And also you can swing by my office and grab a Kahoot t-shirt. Lots of mediums, 1XL left. Here we go with the next question. Let's do it. UT is 20% juniors also. From 80 students, 30 are juniors. Find the mean of the sampling distribution. I'll give you hints in a second. Find the mean of the sampling distribution. Well, think about what you have. You have right here P. From P, you can find Q. That's Q. Not the answer. You have here N, sample size. You have here X, 30 over 80. That's 37.5, which is going to be P hat. But wait, the mean for the sampling distribution, that's mu p hat, and mu p hat is p. So I think a lot of people get scared by this. The mean for the sampling distribution, don't worry if you got it wrong. Do you see where this says the mean right there? You see this says mean, mu being mean. So if it says the mean for the sampling distribution of the sample proportion, all you're looking for is what? The mean for the sampling distribution of the sample proportion, all you have to find is what? The mean, so just tell me the notation I'm looking for right now. The mean for the distribution of the sample proportion. The mean for the distribution of the sample proportion is equal to what? I'm just looking for this. It's P. So you go to the question, you say, oh, you want the mean for the sampling distribution? And we're dealing with proportions because it's people are juniors or not juniors. So UT is 20% juniors. That is P. That is a statement of fact. So the mean for the distribution of the sample proportion is P. So this is asking for mu P hat, and the answer is the true proportion. Does that make sense? It's a tougher chapter. It's a tougher chapter. So it really boils down to notation. You're welcome. I try to be a nice guy. I try. Leaderboard time. Aquatic Panda back in the lead. Hero Jaguar just nipping at their heels. Excited Eagle and Funny Cat, Inspired Bobcat. It is the top three. Should email me the top three. What is the difference between this question and the last one? The first one, it said, what is the true proportion? P. The next one said, what is the mean for the sampling distribution? Well, that is asking you for mu P hat, but mu P hat is P. So it's knowing that if it says, like, what is the truth, you're finding P. And then if it says, what is the mean for the sample proportion? Well, that would also be P because mu P hat is P. It's a concept that the mean for the distribution is P. Good questions, Noel. It's a tougher chapter. Don't worry. Let that inspire you, because if you ace it, you'll be like, yes. We know that UT is 20% freshmen. We sample 200 students and 30 report being freshmen. What is P hat? Practice, practice. Watch the speedrun videos. Watch the reviews. Let your notes guide you. And ask questions. Join the Discord. Does Mubot? He should tell us the Discord in here. I think his links still work. I will say this. If you make B's and C's on the test and do all the work, you can still make an A in the class. The tests are the hardest part. Good few questions here for people to practice. You're welcome. P hat stands for sample proportion, which would be 30 over 200. A lot of people got this. Mubot is just, you say good and Mubot does that. He has a lot of fun things in here. Bunny. He's got a lot of fun little things, or Bama. So there we go. He's putting bunnies. He doesn't have a gator though, apparently. There we go. Aquatic panda, hero jaguar, excited eagle, funny cat, inspired bobcat. Let's go next question. Last one. UT is 20% juniors from 80 students, 30 are juniors. Find the standard deviation of the sampling distribution. We're going to get done right before 2. This is quote 191. So you got to see a little bit, Blake. I'm glad you got. And Marley, everyone who's here, who's new to this experience, I'm glad you got to see it. Mubot is our robot. He just told you in the chat, P times Q over N square root of the whole thing, not just N square root. So P times Q over N square root. P times Q over N square root. So you got to find P, which is 0.20. You got to find Q, which is 0.8, the complement of P. So we go right here and we say P, which is that, times Q, its complement, divided by N, and then you square root the whole quantity. P times Q over N square root. What's my favorite bar? A space bar here? A hoot? Mubot. Why is Mewtwo spamming the chat? He does that. He does that. He's a spammer. He's a spammer. Just spamming the Mubot. Stop it. Stop it. Just stop it, Mubot. Let's go to leaderboard. Here we go. Leaderboard time. I don't get the animations anymore. Aquatic Panda in the lead. Make sure to email me. Hero Jaguar. That was close. Glad to thank everyone who got on the leaderboard right there. $20 Amazon or Starbucks, your choice. Also a Kahoot t-shirt if you want. But I do want to advertise once again as Mubot is just spamming up the chat. He just... Mubot, that doesn't even make sense. You're not even typing anything anymore, Mubot. But one more time, Mubot, tell us where review 2 is so that way people can go to it and check out the review right there. But it really comes down to starting early, asking questions, practicing doing the questions. I promise it will pay off, and I've dropped a lot of hints. You're welcome, Blake. I hope this was very helpful. Remember, my email is bstevens@utk.edu if you have questions. I am on the Discord, and we've got Sarah and lots of great people. I'm confused on how to recognize when using X over N. Any question that wants X over N is going to ask you, what is the sample proportion? X over N is the formula for sample proportion when a question asks, what is the sample proportion? And I'm here on campus. You might see me walking around. Feel free to say, hey, Brian. And I'll be like, hey. And I'll be like, hey, how do I know you? And you'll be like, I'm in 201. I'll be like, oh, cool. Good to meet you. You're welcome, Marley. Good to see everybody here. I'm going to go home. I'm going to relax. I'm going to eat some lunch. Maybe some Taco Bell. But maybe not Taco Bell because I got to be Deadpool in a few days. Not that you heard me say that here. You're welcome, Jasmine. Thank you, Jasmine, Marley, and Blake. The exam is on Tuesday. Big review on Tuesday. Big. More Morty, yes. Let's go grab him in the car. I'm going to go end here with a picture of Morty driving his car. I did promise that. So let me go grab the Morty picture. In pets, there's a picture of Morty driving his car. And Morty lit. Oh my gosh. Okay, here's passed out Morty. I gotta find the driving car Morty though. This is our Texas apartment. So here's passed out Morty. There's Morty passed out on the floor. He would sleep under the chairs all the time. Just Morty passed out. Just bun flop. And I know I have another one. Where is... Oh wait, that's not... I found another one where he's on a little thing. but I know I put the picture of him driving his car here. It's my wife and I's rabbit. That's Morty. So I'm trying to I'll try to find the car one. Oh, that's across everything. Driving. Trying to find it. Like, we'll drive you crazy. Where is he? Try to find him. Yeah, I want to find the picture of him driving the car. I know. Give it one more moment here. We have so many pictures of pets on Discord. Lots of... Oh, I found a picture of Jolly. I'll put a Jolly picture in the chat. Just chilling for a moment. We'll put on a little chill music here. There's a picture of Jolly. A little chill music while we do this. Just I find pictures of our pets right here. There's Jolly Bunny. That's Jolly eating his greens. And then... Oh, there's Morty again. I posted so many pictures of them. Some more Morty, more Jolly. There's another Morty. I have a lot of pictures of them. There's Morty again. They've got low pile carpet because rabbits will eat carpet. They will get impacted or bezoars or things like that. So if you want to... I'm trying to find the one I love. Found it. Found it. Found it. Oh, it's him driving his car. It's the cutest ever. There he is. That is our little boy's turned into a man. Driving his car right there. This is just... That is my favorite picture of Morty. I've got a bunch, but like, just him inside of his car right there. It's where it looks like he's got his hands on the wheel. I mean, he should. He's driving the car, so just... You can probably see where he was like eating it. They'll just eat... He ate his car. We had to throw away his car. He destroyed it. So that's... It's, you buy these little, they have them at like PetSmart or whatever, these little cardboard things, and rabbits and cats will like, so a lot of the cat ones have like claw things in it, and so the cats will go in these and like just claw at it, but Morty will go in there and he'll go like, he'll just like bite at it, and then it'll just start falling apart, like eventually just like it's destroyed. The funnest thing is we talked about his job. Yeah, exactly. Thank you so much, Marley, right there. So Morty, in this area we had in our apartment in Texas, so we had it roped off so he could go around it, because he can't be, they'll eat wires. You don't want to have reps in your wires at all. They'll eat them, and hopefully the wires are not plugged in, but still bad. But he had this cardboard area we had roped off so he wouldn't go towards the wall and like mess with the wall too much, and he would go into the boxes, and we talked about like he was going into like his coal mine, and he was like going in there and like doing his job, and be like, oh, Morty's at work again, and we just hear rip, 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 because he'd be like pulling at it, like he'll like bite at it and pull and rip at it, and he literally, it was like a refrigerator box or something, and he ate like over the course of like a year, he ate the box so much it was just destroyed, and it was just fun watching it go down. We're like, oh, and eventually the box is like falling over. We're like, I got to toss away this box. It wasn't a refrigerator box, it was something else. It was a very long box, it wasn't like as wide, but he would go into it. It's about as wide as him, and he'd go in, bite all around it, and we just look, and the box is just deteriorating over time. But he loved it, and it's not bad for rabbits. He's cardboard. Give him lots of hay, give him lots of greens, not a lot of carrots. That's high in sugar. Bunnies do not need a lot of sugar, or else they'll get kidney stones. So with that, thank you, everybody. We'll do one more fun outro here. So probably my favorite outro, one of them, is the NES one. So bye for now, everyone. Bye!